strange feeling because I'm not dengue researcher, and Jake is going to talk about dengue study. I became his mentor last year when his true mentor, Northman, moved to the University of Rhode Island. Unfortunately, Alan cannot come today because of the conflict of schedule, but for the sake of emotional support, I will so, do you feel more relaxed now?
Yes, thank you.
Okay. Yeah. So that you can stop now.
Thank you, Masanori. And this is my family actually coming in here. Lots of family coming in.
I missed something good, obviously.
Well, thank you for being here this afternoon. Masanori was generous to take me on this past year, but most of this work was done under Alan's advisement and is focused on the regulation of IL-8 by antiviral proteins. Now, an overview of my talk and what I'll be covering today. I'm going to start with some epidemiology and clinical background of dengue, and then go over the virus itself, and then talk a little bit about my favorite inflammatory mediator, interleukin-8. And then I'm going to cover 3 main points today with my thesis. The first being I intend to show that multiple dengue viral proteins contribute to transcriptional activation of IL-8 during infection. The second being to show that expression of dengue virus NS5 activates TNF and RANTES, two inflammatory mediators, also regulated by the transcription factors AP1, CBP, and NF-kappa B that regulate IL-8. And third, I'm going to show that dengue virus proteins that activate the IL-8 promoter also activate AP1, CBP, or NF-kappa B. I'll close with a model of how dengue virus interacts with the IL-8 secretory pathway and how IL-8 fits into the pathogenesis of dengue. Dengue virus itself is transmitted by the mosquito vector Aedes aegypti, pictured here, and is distributed across tropical and subtropical regions worldwide. Approximately 2.5 billion people are at risk of dengue infection worldwide, which is about half the world's population. Now, the vast number of infections are asymptomatic, illustrated here. A percentage of infections do show symptoms, predominantly a fever, characterized by this febrile phase, at days 1 through 3 of symptoms. Usually, the febrile phase will resolve itself and move into a recovery phase. However, a percentage of infections actually move into this critical phase here, where dengue hemorrhagic fever or dengue shock syndrome, 2 severe forms of dengue, can actually develop. Now, DHF is predominantly characterized by vascular endothelial cell permeability without cell damage. And this has been the focus of my research. Dengue is a member of the Flaviviridae, which includes clinically relevant viruses such as hepatitis C. It is also a mosquito-borne flavivirus, which includes clinically relevant yellow fever virus and what people are more familiar with around here, West Nile virus. Dengue is also not just one virus, but 4 very closely but antigenically distinct, very closely related antigenically distinct viruses, dengue virus 1, 2, 3, and 4. And this means that patients may actually be infected multiple times with dengue virus throughout their lifetime. Infection with any single virus, a primary dengue virus infection, leads to DF most commonly, dengue fever, though dengue hemorrhagic fever can occur. Once that infection resolves, there's lifelong immunity to that primary infecting serotype. There is a transient immunity to the other 3 dengue virus serotypes. However, once that transient wanes, their patients are susceptible to a secondary infection. And there's actually an increased risk of DHF and DSS. And this was some of the first evidence that dengue pathogenesis is actually immune-mediated. Dengue virus infection begins with receptor-mediated endocytosis. Once taken up into cells, upon acidification in the lysosome, the dengue genome is released and immediately translated. As a positive sense, mRNA is capped, but it does not have a poly A tail. Translation of dengue virus leads to a polyprotein that is co- and post-translationally cleaved into 10 viral proteins. The capsid, the pre-membrane, and the envelope are the 3 structural proteins, and then non-structural proteins are NS1, 2A, 2B, 3, 4A, 4B, and NS5. All of the non-structural proteins have a role in replication, which occurs in perinuclear endoplasmic reticulum-derived membranes. This is a picture of NS5 here. Once viral genome replication occurs, the genome is encapsulated in C protein, and budding into the structural proteins E and pre-M occurs in the endoplasmic reticulum. New viral particles are processed through the trans-Golgi network, where pre-M is cleaved by the viral protease furin into the membrane protein here. And new virus is exocytized from the cell. Relocalization of the viral proteins does occur throughout the course of infection, including NS5 and capsid to the nucleus. And I'm just highlighting a few proteins that I'll be discussing in more detail later on in the presentation. I also discussed pre-M and E here. I have a construct that actually expresses pre-M and E together. And the significance of this is that, like full virus, it can actually form a bud in the ER, be processed through the trans-Golgi network, and exocytized from the cell. However, this is empty virion. It does not contain any viral RNA, and therefore is non-infectious. These are called virus-like particles. NS4B is another protein that I highlight later on that relocalizes into the cytoplasm. And NS1 protein is usually secreted from the cell. However, there is an alternative form of it that we have termed here NS1G that contains 26 amino acids of the NS2A protein. This adds a GPI linkage site to the protein that actually anchors NS1 to the cell surface. I also want to take this opportunity to highlight that several of the dengue viral proteins interact with very important signaling pathways, such as blockage of the antiviral interferon pathway, or inducing apoptosis, or in restructuring